Hey everyone, as you can tell by the title of the ping board, we'll be looking at the polynomial fractions or the rational functions, alright? Because this is in conjunction with our discussion for horizontal asymptotes and actually basically any of the asymptotes really, alright? So let's start with the idea, or an example rather, and let's say we have 1 over x minus 1. So what is the what is the vertical asymptote? It's basically the value that lets the function be undefined. So we have x equals to 1, right? Because you get 1 divided by 0, which is invalid or undefined. So we have our first vertical asymptote at x equals to minus 1. Now, the next part is there a horizontal asymptote or an oblique asymptote? Now, what you do is very simple. Let x approach infinity or negative infinity. You notice that if x approaches infinity, it's 1 over a very large number, so this will approach 0 from the positive side. As x approaches negative infinity, now you must consider the other side. 1 over x minus 1 would also approach 0 because it's 1 over a very large negative number. But now this time it will come from the negative side, right? Because x minus 1 would be negative when x approaches negative infinity. As such, we have our horizontal asymptote at 0 and 0 because in the long term, our value of the function would approach 0, and therefore we have the asymptote y equals to 0. That's the analytical way. The I power way is very simple. Whenever you see kx plus c equals, kx plus c plus j over fx, where fx is a polynomial, the idea is that this will be your asymptote. Right, whether is it oblique, or whether it isn't oblique, or whether it's basically horizontal or oblique, that will be the asymptote. Alright, in this case it is 0 plus 1 over x minus 1, hence your horizontal asymptote will be at y equals to 0. Alright, so now we just draw the graph. So I'm just going to draw the graph like this. Don't forget, your value must go very close to the vertical and horizontal asymptotes. Try not to touch it. I almost touched it there, but yeah, there's a decent sketch, although here could have been a bit more closer. But yeah, I'm not gonna like edit that right now. Alright, so if y equals to x, 1 over x minus 1, this will be the graph. Okay, once again, label all your intercepts with the x's. So clearly you have no x-intercepts because the function can never be 0. But you know, we can put x equals to 0. So x equals to 0, we have 1 over 1 minus, x equals to 0, we have 1 over minus 1. So we have 0, 1 over minus 1 is simply minus 1. Alright, let's move on to the next example. So the next example would require us to do something before we can sketch the graph, right? And the graph would now be x plus 2 over x plus 1. Alright, so again, you must try to get off the form kx plus c plus j over fx. Alright, now here's how you do it. One way is to do long division, right? Something that you are probably very familiar with. Another method, which probably some of you would have known, is basically kind of group them based on the linear denominator. So I split to x plus 1 plus 1. So I get x plus 1 here, x plus 1 here. This will give me 1. Now I get plus 1 over x plus 1, so plus 1 over x plus 1. And continue the fashion, this will be our asymptote. So we have y equals to 1 as our asymptote. Then we have x equals to minus 1 as our vertical asymptote. Now we just need to draw the graph. Alright, so the graph will look something like this. Of course you can use a GC, but I'm not going to. Alright, look something like this. Okay, so this will be the graph of, you can either put it as x plus 2 over x plus 1, or you can convert it to 1 plus 1 over x plus 1, but I'm just going to use the original one because it's slightly easier. Again, put in your intersection points. So when at y equals to 0, looking at the original graph, when y equals to 0, the numerator must be 0. So it will be at minus 2, 0. Then for the y-intercept, x equals to 0, you get 0, 2, right? 2 over 1. Alright, so this is basically polynomial fractions, rational functions with horizontal asymptotes. I'll go through the one with oblique asymptote in the next video. But just before we end this video, I'd like to say that In the H2 Math syllabus, we have fx over gx, right? Now, gx, degree of gx is either 1 or 2, all right? And correspondingly, fx will then either have degree of 0, 1, or 2 for 1. Otherwise, for 2, it will be 0, 1, 2, or 3, all right? So this would be the general idea for our H2 Math that you see in terms of algebraic fractions. Of course, be prepared to, let's say, solve a denominator with a cubic, let's say kx plus c plus a cubic function, all right? Otherwise, there we have it, polynomial rational functions, where we have a horizontal asymptote.